Now, what are the factors that affect growth? The most important factor is genetics, which is why children born to tall parents are tall. A child is short and he can't expect to be tall if his parents are also short because it depends a lot on genetics. Now, let's take the example of Africa. In Africa, there are certain tribes where people reach up to 6 feet or 7 feet in height, while there are certain tribes, such as the Pygmies, where the maximum height is 4 feet in height. In the same continent, in different places, you have people of different heights. Again, this is genetic. Endocrine causes. There are factors like diabetes, which cause you to put on weight. Of course, certain forms of diabetes make you lose weight. Iron deficiency, where the person puts on weight. Growth hormone excess, where you exhibit gigantism or acromegaly. Nutritional deficiencies, where you lose weight. And nutritional excess, where you put on weight. Stress can affect growth. It can inhibit growth. It could be any form of psychosocial stress or stress due to certain diseases as well. And one of the main factors that affect growth is neoplasia, where the proliferation is because of a damage in the DNA. So the cell cannot control the cell division, so it proliferates without control. But neoplasia is beyond the scope of today's session, so I remove it from this slide. So we focus on non-neoplastic disorders of growth, which is decreased growth or increased growth. Decreased growth is hypoplasia, aplasia, and atrophy. I'll discuss a little bit about all this in the next few slides. Increased growth is non-neoplastic, where the DNA is normal. Now, this growth occurs due to a need. It is a controlled growth. When my muscle grows after I exercise, it is a controlled growth. But if a part of my breast grows out because of a tumor or a cancer, it is an uncontrolled growth. It is not needed. That occurs when there is abnormal DNA. So all non-neoplastic proliferations have a normal DNA, so their growth is controlled. And remember, this is reversible, which means if the stimulus that causes the control is removed, this is reversible. Among the non-neoplastic proliferation, the first is hypertrophy, where the growth is because of increase in size of the cells. The next is hypoplasia, where the growth is because of increase in number of the cells. The third is metaplasia, where it is due to change from one cell type to another. And the fourth is dysplasia, which is disordered growth, or there is no maturation. So we're going to focus a little bit on each of this again in today's session. So starting with reduced growth, the first is aplasia, also called as agenesis. Aplasia, absence of production. Agenesis, absence of formation. So this occurs when a tissue or an organ does not develop. Usually this occurs early in the intrauterine life. So an organ which has undergone aplasia is either not present, or it is present but it's just a small mass of fibrous or fatty tissue and the cells don't function. Now, when aplasia occurs in paired organs such as the adrenals or the kidneys or the lungs, when one organ is affected, the other organ can compensate. For example, when one adrenal has aplasia, the other adrenal is normal. Or when one kidney has aplasia, the other kidney can function normally. But when it occurs in a non-paired organ, for example, aplasia of the aorta. Now, when the aorta is narrow, I can't expect the child to survive. The child would die in a few hours. The same thing, when a child is born with aplasia of the pituitary, the child cannot survive because there's only one pituitary organ. So it is incompatible with life. Now, hypoplasia is less severe than aplasia. Here, the organ is present, but it does not attain its full size. Now, these organs are smaller than normal. They do not function well because they don't have the full amount of cells. And this affects the same paired and unpaired organs as aplasia. Now, here is a clinical picture of aplasia of the teeth. You can see that the teeth have not developed here. This is a kidney, normal in size. This is a hypoplastic kidney, a kidney with hypoplasia. Notice it looks almost like a normal kidney, but just slightly smaller in size. Now, this is a hypoplasia of the scapula. This is a normal scapula, and here there's a hypoplasia. So the child cannot lift up his shoulder, and the child has to hold his, needs support for his shoulder.